Hello. So last time we were introduced to a position versus time graph along with their functions. In class, you should have practiced the packet method to obtain data to make position versus time graphs and correspondingly their position as a function of time equation. This video is to extend that idea to associate different objects moving at different velocities and how they might relate to each other. Let's take a look at the following equations you see in front of you that describe constant velocity motion for two different objects. One is a red car, and the other one is the blue car, denoted by the color. First of all, before we do anything with these equations, take a moment to just flesh out what these objects are doing. Write them down in your notebook, just like a word description of how they're moving, and pause. I'll read out the answer in the video so you can check after. Okay, so you have your answer written down. Just by inspection, both the red car and the blue car are moving in the positive direction. Now you might ask me how I know that. I know that because if I look at the 2 right here, and I look at the 4 over here, they're both positive numbers and they both represent the velocity of the object, meaning that if they're positive, they're moving the positive direction. If one was negative, then one would be moving in the negative direction. Remember, velocity is a vector, and the sign tells you which direction that vector or arrow is pointing. Okay. Secondly, what's different about them is that the blue object is actually moving faster than the red object by 2 meters per second. The difference in speed or velocity is 2 to 4. So I know that the blue object is moving faster in the positive direction. The other thing I notice is that while the blue object is moving faster, the red object actually starts way ahead in the positive direction of the blue object. The starting point of the red object is at positive 20 meters. The starting point of the blue object is negative 3 meters. So one of them has a head start if they're both moving in the positive direction. And that's what I see from these two equations, just by visual inspection. So, what else? Let's take a moment and draw an x versus t graph, or a position versus time graph, representing the motion of these objects. This time, we're going to put both lines on the same axis. Pause here once again, try it on your own, and I'll show you the answer in a few seconds. Okay, so let's take a look at how we're going to draw this. First of all, I'm just going to get some axes going here. I'll put that in a different color. Okay, so I'm going to draw the axes. Like so. And then I'm going to label my axes. So this is going to be a position, so an x in meters. And this is going to be in time, in seconds. Fix that a little bit. There you go. Okay, so first I'm going to draw the red car. I know the red car is moving at 2 meters per second in the positive direction, so I know it should be going up on the position versus time graph as time goes on. I'm going to label out 20 meters here. You don't need to make tick marks with me. Don't bother doing that. Put a label on there, label it 20 meters, and then place the line down. Now the line that you should see, this would be not moving at all. This would be moving in the negative direction. This is moving in the positive direction. You can see that the position is increasing as time goes on. Okay. And then the last thing that I'm going to do, just to make sure I know all the information to recreate this line, is I'm going to put a little like slope denoter there in the form of a triangle. I'm going to say 2 meters per second. That's fully labeled. I know exactly what the equation is if I need to go back from the graph and get the equation. And so that's all I need to do. Okay, now here's the thing. Now I'm going to graph the other line. This other line is going to start down here, and so 20 meters, probably, this is probably like -3 around here. Doesn't have to be perfect, as long as you label it. So -3 meters. Notice how it starts below the axis because it's negative. Now, here, my line, this would be moving, not moving at all. This would be moving in the negative direction. That's not right either. Remember, we agreed that it was moving in the positive direction, faster than the red car. Since it's faster, if they were moving the same speed, this is what it would look like. Notice how they're parallel, because they would have the same slope or the same velocity. Now, if I increase the velocity to double, it would make it steeper. Something like this, roughly. Now, I'm going to finish off my line with the triangle denoting the velocities. That's 4 meters per second. So I'm going to give you a moment just to look at this. Look at this and see what you notice about this graph that we haven't seen before, because now we have two lines on the same axes. So now looking at this result, if you were careful and made sure that the line of the blue car was steeper than the line of the red car, you see that they intersect at some point in time. This intersection represents something very important with regards to the two objects. What do you think that is? That they intersect right here. If you guess that that's where they meet in real life, you'd be correct. This point in the graph, highlighted by that yellow circle, tells me that those two objects at that point in time meet at that particular position. And that's really, really important because now we can mathematically find when two objects meet. Since the equations on the screen give position, I know that when the objects meet, they'll have the same position at the same exact time. If I take those equations which represent position and set those equations equal to each other, that means I can take that equation, solve for t, and figure out the time at which when they meet. So let's do that for 1 second. So in a different color, I'm going to set 2t plus 20 equals to 4t minus 3. Solving, really simply, I'm going to get, now be careful with your sign. I'm going to get 23 equals 2t. Solving for that, I get t equals 23 divided by 2, which is like around 11.5 seconds, I think. I did that in my head correctly. Okay, so I can say that, hey, these guys meet at 11.5 seconds. If I take this 11.5 seconds and I plug it back into these equations right here, so if I take this number and I say, I wonder if I took 11.5 seconds and I put it back into this equation, what number should I get? So I get 11.5, plug that into t, or 23 over 2, plug that back into t, I get 23 plus 20. So I get, the position would be 43, right? So 43, I'm going to write that down there. If I go to the other one and I take this and I take this guy, and I take 23 over 2 and plug that back into 4t. So I'm like, okay, let's plug that back in. If I plug 23 over 2 times 4, that gives me, what, 46 minus 3? 46 minus 3 is 43 meters. So you notice that if I take the time at which they're supposed to meet, and I plug them back into the appropriate equation, then I get the same position, which is what you should have. This is a good way of double checking your work. If you messed up something in the equation here, you won't get the same answer here and here. So I know that these two objects, the car that's red and the car that's blue. So I know for the red car and the blue car, if they're both moving with these equations, they'll meet at 11.5 seconds at 43 meters. Now we've just successfully combined graphing, geometry, algebra, and real-life physics if you were doing this in the classroom, which you will. See if you can do the same thing that we just did and find out where other objects will meet with the equations below. If there's something fishy, be sure to tell me why it's fishy. We'll go over the answers in class. So I'm going to write down two new equations right now for you. Alright, so these are the two equations I want you to use. Or rather, two sets of equations I want you to use. The first set and the second set. The orange car, the purple car, the paisley car, and the plaid car. Okay, so see if you can figure out how those objects interact in terms of on a position versus time graph, and see if they meet. You can figure out when and where they meet. If you can't figure that out, try and explain why. Thanks.